The vapors inside chemical tanker trucks can build up pressure due to changes in temperature or when they shift during transport. To prevent this pressure reaching dangerous levels, special vents maintain the balance between the forces that want to implode or explode the chemical payload. These pressure relief vents are standard equipment in this high-pressure business. So, let's blow the lid on the secrets of these unsung heroes of the chemical transporting world. Production starts with the bin of casting-grade wax pellets. These pellets are used to mold wax models of some of the parts, in a process known as lost wax casting. The pellets are fed into an injection molding machine. The machine melts the wax as it forces it into a mold of the vent's lower housing. The wax then cools and solidifies. 4 of the models are then fused to a wax tree stand and are left to cure for a couple of hours. Then, a metal rod molded into the center of the wax tree is used to dip the mold into a spinning ceramic slurry. The wax models are now removed and twirled in order to drain off the excess ceramic. This is the first of several ceramic coatings. Between coatings, silica sand is applied to the wet ceramic. In this chamber, the sand rains down onto the ceramic, creating a stucco effect. By building up layers that are progressively more coarse, a ceramic shell with the desired thickness and strength is created. To apply the final coarsest layer of sand, air is pumped through it as the models are dunked into it. This ensures a uniform coverage of the heavier sand. The forms are now baked to melt the wax and harden the ceramic, creating a shell. Next, red-hot molten steel is poured into a ladle. The ceramic shells are then removed from the oven, which has heated them to more than 1,600 degrees Celsius. The hot steel is now poured into the shells through an opening in the wax tree. A chemical sealer is added before the molten metal is topped with a piece of ceramic fiber insulation. The castings are then left to cure. It takes 3 hours for the steel to solidify, after which the ceramic can be shattered to reveal the steel vent housing parts. The parts are removed from the tree using a circular saw, before any ceramic residue is cleaned off. 15 computer-driven tools are required to machine the pressure vent housing part to precise measurements. After cleaning and polishing, the part is complete. It's time for assembly, starting with the top of the pressure vent. A large spring is inserted to aid the pressure relief action. A metal plate is then added, which will act as a seal between the upper and lower parts of the vent. The lower vent housing is then positioned on top of the plate. The assembly is now placed under a hydraulic ram. The ram presses the lower housing, the sealer plate and the spring to a specific tension. The lower housing is then screwed to the top of the vent. A metal ring inscribed with the vent's model number and flow rate is now added and riveted down. The chemical tank pressure vent is now complete and ready to be put to the test. The technician screws it to the test stand. The system forces compressed air into the vent to confirm that it works at the desired settings. Once approved, a weather cover is attached to the vent. A laser is used to etch the serial number into the unit to allow the vent to be tracked if needed. Now complete, this vent is ready to prevent any hazardous situations. Although sadly, It won't stop the driver blowing his top if he gets stuck in traffic. The candy wafer is a classic American confection that's been tickling taste buds since 1847. These thin, featherweight discs of sugary candy are softer and faster dissolving than a hard candy, which gives them, of course, that classic melt-in-the-mouth effect. These candy wafers come in 8 flavors. The original roll has a random assortment of 38 pieces. So, if like me you're really picky, you can choose a roll that has more of your favourite flavours. The factory makes one flavour at a time. The first step is to add a blend of food colouring and flavouring to powdered sugar. This pink colour and mint flavouring produces winter green flavour, which apparently is quite minty, especially in the winter. The next ingredients are corn syrup and a binding solution made of vegetable gums and gelatin dissolved in water. After mixing for 8 minutes, the consistency of what is now candy dough is checked. If it isn't sufficiently thick, elastic or sticky, more binding solution is added. Next, the dough is divided into chunks, which are fed into the dough sheeter, the first station on the wafer forming line. This black dough is licorice flavour. A conveyor returns leftover dough from the end of the line to be reused in new wafers. The dough sheeter compresses the dough and extrudes it through a slot to form a sheet that's 50 centimeters wide and 2.5 centimeters thick. This yellow dough is lemon flavour. A steady sprinkling of cornstarch prevents the sheet from sticking to the equipment, as rollers compress and stretch the dough until the sheet is just 3 millimeters thick. The next station stamps on the company logo before cutting out the wafers. The cutter moves up and down 180 times per minute, and the freshly cut wafers fall onto a conveyor belt below. This ferries the wafers to a multi-level tunnel dryer. Over the course of an hour, they'll pass through the dryer 13 times, a total distance of 18 meters. These green wafers are lime flavour. The dryer is set to 65 degrees Celsius, which is warm enough to remove about half of the moisture without melting the sugar. These brown wafers are, of course, chocolate flavour. Once partially dried, the wafers are stiff, allowing them to be placed in trays without sticking to each other. The trays are stacked in the drying room, which is heated and humidified with steam. It'll take 16 hours to dry out the candy wafers until their moisture level descends to less than 1%. The factory tests samples by jabbing them with a device called a penetrometer. It measures the force required to penetrate the candy wafer until it breaks. This ensures the candies have achieved the perfect consistency, although I could do that test with my teeth. When the trays come out of the drying room, they're tipped into a single bin. This mixes the candies, ensuring that every packaged roll will have a random assortment of flavours and colours. The wafers now flow into channels which stand them on their sides. The roll-sized channels of a conveyor belt are now filled with candies, which will move them to the wrapping station. Any remaining gaps are filled to ensure each roll has exactly 38 pieces. The wrapping machine cuts the translucent paper wrapper from a spool and applies a bead of glue to one edge. In a matter of seconds, the machine lifts the roll into the wrapper, seals the edges, and twists the ends closed. As the sealed rolls move along a conveyor belt, heated blocks iron the twisted ends flat. The rolls of candy wafers weigh just 57 grams and are now ready to be packed into boxes. In addition to the traditional roll with assorted flavours, the factory also produces all chocolate rolls. And while some aspects of production have been modernised, the recipe itself hasn't changed a great deal since the first candy wafers rolled off the production line in 1847, which, if you ask me, is rather sweet.